All right, this video is on section 4.3, which is proving triangles congruent through two theorems, the side-side-side theorem and the side-angle-side theorem. And these theorems, it's important that you go based off what is labeled and what is given to you to use these theorems and prove that triangles are congruent. Okay, so the first one we have here is side-side-side, and you'll see that abbreviated as SSS. And this is saying that if three sides of one triangle, so let's say we have this triangle here, correspond and are congruent to the three other sides of another triangle, then you can assume the two triangles are congruent. So this side and this side match. They're congruent because they're both labeled with one mark. This side and this side, these are also congruent because they're both labeled with two marks this time. And this side, my 3 mark, is congruent to this side, my 3 mark. So because I have a side, and a side labeled for each triangle, then I can say, oh, that's called the side-side-side congruence theorem. Okay. The second option here is the side-angle side. So in this one, I'm going to need an angle. It needs to be the included angle. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then these are congruent. So here's what I mean by included. I have a side, and immediately if I'm following, like if you're walking along this triangle, then you have an angle. So you start off with a side, and then you keep walking along the triangle, and then you have a side. So the angle is sandwiched between the two sides. Okay, that's why it's side, angle, side. Same thing over here, and the corresponding segments here. This side corresponds to this side. This angle corresponds to this angle. And again, the 2 marks corresponds to the other side that's also congruent. So this would be side, angle, side. So the difference between the two is that for one, the 3 sides are marked as congruent. And for the other one, there's an angle sandwiched between those sides that have it be congruent. Okay, so let's see if we can identify given these two pictures. So determine whether these triangles are congruent by side, 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 or side, angle, side. So looking at this first picture on the left, I have a side here marked with 1 mark, so I know these two sides are congruent to each other. Then I have this side over here marked with 2, which means it's congruent to this one over here. And then I have something interesting that's going to happen a lot in these sections, and it's going to be that they share a side. If something is shared, then we have to assume that it's the same measurement because they both share it, okay? It's not like it's sticking out somewhere over here or anything. So this one has 3 sides, a side here, and the side they share, side, side, and the side they share. Therefore, these two triangles are congruent by the side, side, side congruence postulate. The picture on the right, we have a side that corresponds to this one. We have another side over here that corresponds to that one. But between those two sides, I have an angle, and these are vertical angles. They're across from each other, so they're congruent. Therefore, here I have a side, and then I have an angle, and then I have another side. A side, an angle, and another side. That's why it's the side, angle, side congruence postulate. Okay, so again, go based off of what they are giving you. Sometimes your pictures will have more than one congruence theorem, but you never want to make any marks yourself. The only one that you can assume if it's not given to you would be vertical angles, because we learned about those and we know vertical angles are congruent. So if vertical angles are not marked on your picture, those are the only ones that you're able to go ahead and mark yourselves. But like in this picture, for example, too, I wouldn't go on and like add a 3rd mark over here if it's not given to me. Don't do that, okay? Just go with whatever the picture is giving you to begin with. Okay, so for example 3, it wants me to write a proof to show that these two triangles are congruent. So let me mark whatever I am given. So I'm given that EI is congruent to FH. So EI is this one, and FH is this one. It's also telling me that G is the midpoint. So here, that's the middle. Okay. And it wants me to prove again that these two triangles, essentially, let me go ahead and highlight them, like this triangle and this triangle are congruent. That's what it wants me to prove. So I'm going to go ahead and write a 2-column proof. I know it's been a while since we've done proofs, but on the left side, we're going to have our statements. And on the right side, we're going to have our reasons. And remember, the first reason should always be given. So start off with whatever they tell you. And here they give me quite a bit of information. They tell me that EI is congruent to FH. And they also tell me that G is the midpoint of EI and FH. Okay, so that's my first thing. They told me that that's the midpoint. So then think about, what does the midpoint do? What does the midpoint do for a segment? Okay, and hopefully you're thinking that it's going to split it in two. So what this midpoint is doing here, it's splitting this half and making it equal to this half. So that's going to be my next statement here, is that EG, I'm splitting it in half now, is going to be congruent to GI, and that's going to be by the definition of midpoint. Okay, the midpoint splits it in half. And it's doing the same thing to my other segment, so my other part, FG, and I'm not going to split it up into two different reasons because it's the same reason for both. FG and GH, this one, are congruent to each other by that same definition of midpoint. Okay, so now let me clear up my picture a little bit here. What I have proven by the definition of midpoint is that this and this are congruent, and this and this are congruent. So far I have two sides. Okay, I have two sides that have been proven to be congruent by the definition of midpoint so far. Now, I also should say something about the angle, because I can see that these right here are vertical angles. So remember I said those are the only ones that you can draw in and assume. So that's angle FGE is congruent to angle IGH. Okay, and that's by the definition of vertical angles. So vertical angles are the only ones that if they are not drawn in, you can definitely do that. So because now I have side, an angle, and a side, and over here a side, an angle, and a side, my last statement can be that these triangles are congruent. Remember, your last statement should always be what you're trying to prove. And my reason here is because I prove that there's a side, an angle, and a side that are congruent to each other. Okay, so I just proved that theorem. And we're actually going to stop here for the notes for 4.3. We are not going to go on to the back. So from here, you should be able to do your practice.